Welcome back, ladies and gentlemen. Today we're working on a review, and just going to walk our way through this, just kind of explain all the different properties. It's not like these properties are overwhelming, but there are a lot of different ones going on, so again, hopefully this video helps. Okay, so for one, it says use the properties of rational exponents to simplify the expression. We have the same base. Same base, we want to add the exponents. So we're looking at doing -2/5 plus 4/7. Okay. Now I need a common denominator. So in this case, my common denominator would be 35. So I can multiply the top by 7 over here and get -14 over 35. And then to get that one would be multiplied by 5, so I would get 20 over 35. If I can reduce that down, I would get 6 over 35. We always check to see if we can reduce that down. In this case, we cannot. Boom, you're done. All right. You guys can, if you would like. All right. Since we have the graphing calculator, I could do -2/5 plus 4/7. Okay, just showing you again. Math. Enter. Enter. Okay. 6 over 35. We're in good shape. Okay. Please note the difference here for number 2. I don't have the same base. Over here I have just one thing. I have a power raised to a power. Well, in that case, I have to multiply my exponents. Okay, so we're looking at, I multiply numerators and multiply denominators. I'm going 5 to the 15 over 8. I look to reduce that down if I can. In this case, I cannot. Boom, moving on. Okay, very good. Number 3. Everything's under the cube root, so I could rewrite this as 56 divided by 7, all of it under cube root. Well, if I divide 56 by 7, I get 8, so now I have the cube root of 8, okay? And I think you guys know this, but just to show you again, hit the math button. The fourth one down has cube root. I can type in 8. My answer is 2. Okay, so again, we're just trying to simplify things down. Here, everything's under the fourth root, so what I can do for this one is I can do 2 times 4 times 2, all of it under that fourth root, which would end up giving me 2 times 4 is 8, times 2 is 16. Okay, so I can't have the fourth root of -16, but that negative is chilling out front, so I'm going to let that out front, and then the fourth root of 16 is 2, so my final answer overall is just -2. Okay, very good. Write the expression in simplest form. Okay, so again, you do need to know perfect cubes, perfect squares, so on and so forth. For here, the perfect cube that can go into 72, okay, not square, perfect cube would be 8. So 8 can go into that 9 times, okay, which I know is confusing because we talk so much about the square root of 9, but this is the cube root of 9. That's not a perfect cube. The cube root of 8 is 2, and I let that cube root of 9 hang out back, and I'm all good. All right. Just to show you guys a quick check, I could do math, cube root 72, okay, and 2 cube root 9. Are they the same thing? Yes, we know we're good, okay? Obviously, you don't want to give your answer as a decimal. Right? When it says simplest form, you always want to just reduce things down. 6 cube root of 7 minus 23 cube root of 7. I have the same cube root of 7 behind it. So I have to just work with the outsides. 6 minus 23 is -17, but I still have that cube root of 7 behind it. And there we go. I can't do anything else to simplify down. Okay. Number 7. We never want to leave any kind of root in my denominator. So since this is a cube root, I need to turn 9 into the next highest up perfect cube. So just, again, these should be 1, 8, 27, 64. That's the first perfect cubes, like 1 cube, 2 cubes, 3, so on. So can I turn 9 into any one of these over here? Hopefully you guys can see I can turn 9 into 27. But what do I have to multiply it by? Well, I have to multiply it by 3. So I'm going to multiply top and bottom by the cube root of 3. Okay, so up top, I'm just multiplying numerators now. Cube root of 7 times cube root of 3 is cube root of 21. And this gives me the cube root of 27. And this is what's so helpful, because the cube root of 27 I can reduce down to 3. So we've eliminated, it's supposed to be a cube root there, we've eliminated that root in the denominator. Okay? Very good. So again, just trying to clean things up. Number 8, okay? I have the fourth root of all these different variables. So we went over this in class, okay? You can rewrite all of these as 13 over 4, 22 over 4, 21 over 4. But let's work our way through. How many times can 4 go into 13? Okay? It can go in 3 times. So you can pull out x to the third. But what's your remainder? Well, your remainder would be x to the first. Okay? So I'm leaving that out there. How many times can 4 go into 22? 5 times. My remainder would be 2. How many times can 4 go into 21? 5 times. My remainder would be 1. That's it. Okay? I mean, again, it all stems from this, x to the 13 over 4, y to the 22 over 4, z to the 21 over 4, and you're just reducing things down, but keep it simple. Keep it simple and you'll go far with this. Number 9 is very close to number 7. I want to turn my denominator into a perfect fourth. I actually think this is a little bit easier because I have x to the 9th down low. So I need to find the next highest number up past 9 that can be divided by 4. Well, the next highest number up would be 12. Think about it. What do I got to add to 9 to get to 12? Okay, so it's x to the third. All right, so up top, I would have the fourth root of x to the third, y to the 11th, and then down low I have the fourth root of x to the 12th. Well, now I just look to clean things up. Can 4 go into 3? No, it just stays underneath there. Can 4 go into 11? Yep, twice, with a remainder of 3. And then down low, the fourth root of x to the 12th is just x to the third. And we're all good. Okay, can I cancel out those x to the thirds? Hopefully you guys are shaking your head no, because that's under the fourth root and that is not. Okay, awesome. All right, so on to the back. So this is more of the domain and stuff that we talked about, and also a little bit of function operations. Here's f of x, here's g of x, here's h of x. F of x and h of x are pretty straightforward. Hopefully you guys realize it's the same routine. Like if I had to find the domain of each of these first, okay, do I have any even powered roots in f of x? No. Do I have any x's in the denominator? No. So my domain for the first one would be negative infinity to positive infinity. The same thing goes for h of x. Domain, negative infinity to positive infinity. Now, I'm also hoping that you guys are cool with 2x to the 1/4 can be rewritten as 2 to the 4th root, 2 times 4th root of x. Okay. Is that an even powered root? Yes, 4 is even. So my domain there would start at 0 and go to infinity, because you can't have a negative underneath there. Okay? So these are our 3 domains that we will use throughout this workshop, the back sheet. F of x minus h of x. Guys, you are just substituting things in. Here's f of x, x minus 6, minus h of x. Put parentheses around it. Okay, if you don't, you're going to get caught. That minus sign has to distribute to both. So minus 3 plus 2x. X plus 2x, I'm just combining like terms now. That gives me 3x minus 9. There's my final answer. Well, you have to take into consideration 2 original domains. All right, well, nothing's restricted. Look at your final answer. Is anything restricted? Nope, because there's no even power roots. There's no x in the denominator. Boom. Okay, all is well. Okay, f of x plus g of x. F of x is x minus 6. G of x is 2 4th root of x. Can I combine any like terms here? Not really. I mean, nothing. There's no common x's. There's no common numbers. So that's just it. Well, okay. Look at your 2 domains. So I already had, oh, I circled the wrong thing up here. My domain then, you look at your two domains originally, well, what's the more restrictive one? Right there. So my domain just starts at 0 and goes to infinity. Okay? Very good. Okay, a couple more. G of x times h of x. So I got my 2 fourth root of x times my h of x, which is 3 minus 2x. Okay, I can just show you guys this. You can distribute this in. This would give me 6 fourth root of x. I just multiply the numbers. The fourth root of x hangs there. And then over here I'd have, okay, minus 4x fourth root of x. Okay? And you're good there. Like, I mean, you could technically combine them, but this is the more cleaner form. Well, looking at my two domains up here, which one's more restrictive? Okay, this one. If I recheck my answer down here, all it is still just even powered roots. So we're okay. My domain starts at 0, goes to infinity. Cool. G of x plus g of x. Okay, so I have the 2 fourth root of x plus 2 fourth root of x. Well, if I add them together, 2 plus 2 is 4 fourth root of x. Okay? Looking at my domains, again, the only restriction is from 0 to infinity. Okay? I want to include 0. Same thing with my final operation here. Starts at 0, goes to infinity. We're good. Last two then, h of x over g of x. Now, this is actually the trickiest one I think we possibly have, so I'm going to save that one till the end. Actually, yeah, okay. So then g of x over here, g of x is 2 fourth root of x divided by x minus 6. Okay, this one's a little tough as well. I still have to take consideration that I need to have from 0 to infinity, right? But look at your denominator. X minus 6 cannot equal 0, so I also can't have 6. So think about how I write my domain out for this one. I'm starting at 0, and instead of going right to infinity, I cannot include 6. So I put 6 here with a parentheses, union 6 to infinity. So what you're saying is you're starting at 0, going all the way to infinity except for 6. Okay? Once interval notation sinks in, it's actually really simple to write things out. Okay? Back here to 14. This is the trickiest one. I personally think this is the trickiest domain problem that there is. H of x on top is 3 minus 2x. No hindrance there. Down low, though, g of x is 2 fourth root of x. Now, normally, we say that x is greater than or equal to 0 when we deal with fourth or even powered roots. But where is that even powered root? It's in my denominator. Can that equal 0? No. So instead of saying x is greater than or equal to 0, we have to say x is greater than 0. Doesn't seem like a big difference, but you can't include 0 here, okay, in the denominator. So my domain starts at 0, but look, there's a parentheses. That's a big thing. I mean, you might be thinking, oh, these look really, really similar. Parentheses, bracket. That makes a huge difference, okay? So again, a lot's there. Hopefully this video helped a little bit. Take a look at it. Keep up the good work. And as always, good luck, okay? We are all counting on you. And Gandalf's always here to watch it too.